This is 11.1 for statistic class. How we do what we call as a goodness of fit test. This is 11.1. We are in question number 2 here. Mars Inc. claims that its plain M&M candies are distributed with the following colors: green 16%, orange 20%, yellow 14%, blue 24%, 13% for red, and 30% for brown. Using the dataset M&M OK to test the claim that the color distribution is as claimed by Mars using a 0.05 significant level. Now, these percentages given by Mars is called the population proportion P, not P hat. It's not come from the sample, it comes from the population. But when you look at the data, so I go to the read table and get M&M OK, this is the data for the M&M OK. This is a sample. So don't forget, this is a population that you get from the given to us. The data files is a sample. So we're going to use the data files to prove if the population that is given by the M&M's company is agreeable or not. So how do we do this? Is first, we see if we met the requirements. So the first requirement say it's a simple random sample. As I mentioned, any data files that is coming up from the MNOK bears, they're all simple random samples. So yes, we met the requirement. Second, the frequency count for each categories. This is also yes, because you can tell that every single color, we got 6 different colors here, they all have a count. Again, this number that you see in this MNOK, they are not the count, they are just represent the weight of the candy. So this is redundant. So what we're talking about is how many red candies we have, how many orange candy, yellow, brown, blue, and green in this bag of candies. Okay, so we do met the second requirement. Next, we had to figure out if your expected frequency is more than 5. You do have to calculate this, and how do you calculate this is first add up all the candies. So the red, we have 13 red candies. This is sample size. Orange, we have 25 orange. Yellow, we got 8 candies. Brown, we got 8 candies. So we got 8. Blue, we got 27 candies, and green, we got 19. So if you add all this, you got 100. That means that this bag of samples of candy, M&M candies, he has 100 samples of it. And then this is based on the percentages given to us: 16% green, 20% orange, 14% yellow, 24%, 30% blue, 30% red, and 30% brown. So these are given in the question. So how do I find E? We take N times P. This is how you find E in this case. So in order for you to find green, you take N, which is 100 candies sample size, times the green one. The green one is 16%, which is 0.16, is 16. The reason why I put good here is because this number has to be 5 or a lot bigger. So in order for us to do this, orange is 100 candies we have times 20%. We have orange candies 20%. It's 20 orange candy. This is also good. Yellow is 100 times 0.14, which is 14%. This is 14. Blue is 100 times 0.24, which is 24%, 24 candies. Red is 100 times 0.13, that's 13% of red, is 13. And then brown is also the same, 100, which is the total candy, times the 13% of the brown is 13. All of this is good. The reason why they are good is because they are more than or equal to 5. And this number is what we call as expected frequency. So this is something I will ask you in the test, how you find this, and you need to know how to find this, and make sure that all these numbers that you find here is gonna be more than or equal to 5 to fulfill number 3. So now number 3 is fulfilled, so we can go on to so all these requirements fulfilled, so we met the requirements. So a lot of students did not do this in your test, so make sure you tell me, do you met or do you not meet the requirement? So we will continue with step 2 here, is doing hypothesis testing. So the hypothesis testing is very easy to write here. You have to write the frequency counts agree with the claim distribution, and the frequency count does not agree with the claim distribution. And the distribution says what, 16% is this color and this color. So this is actually copy and paste from the claim statements given to us. Step 3 is a sampling distribution. This is a chi-square distribution. Again, we use chi-square for chapter 11. Calculation, this is how we're going to put calculation in this case. The counts in this case is the same thing as what we have here. 13, 25, 8, 8, 27, 19. This is come from the data set in here. But watch out for your probability because you have to align this with the percentages, or in this probability of percentages in this case. So like first thing is a 13%. So in this case, you have to figure out which one is 13% for rate, because I'm talking rate. The rate in this case is 13%. That's why you have a 0.13. You have to change in decimals. Next color we have is orange. So for this case is a 20%. So that's why you have a 0.2. Next we have is yellow. Yellow is a 14%. So that's why it's 0.14. The next one is brown. Brown we have 13%. 0.13, and then blue is 24%, is 0.24, and the last one is green, is 16%, is 0.16. So this that means that this number of candy that you put in counts have to align with the probability given to us in the question. If these two are not aligned with the same questions that is given to us, your answer will be all wrong. So make sure that this is for red, this is for orange, this is for yellow, this is for brown, that is the blue, and the last one is for green. So make sure you guys got that correct. And then you do the chi-square test counts p-prop. This is the same. That's what I want you to write in my test here. And then the chi-square distribution came out to be 6.682. The p-value is 0.245. And again, how do we find the critical value, which is new, is you do q chi-square 1 minus alpha. In this question, the alpha is 5% or 0.05. And then k minus 1. How do we know k is 6 in this case? Is we have 6 different colors, 6 different categories. So we got 6 different colors for M&M. So it's 6 minus 1, or you can put 5. So if you put it in your R, it's going to be 11. Okay, 11.071. So that is your critical value. And then the decision is based on the p-value and your alpha. Since this p-value is greater than alpha, we will fail to reject the null hypothesis. And once we fail to reject, the conclusion says there is not sufficient evidence to warrant rejections of the candy that is M&M planes, that the M&M plane candies are distributed with this following percentages. So again, this is coming up from your question. I just copy and paste it to your claim statement in this case. So this is how we do. This question does not have step 7, which is question. This question doesn't have any questions here. So this is the end of this this section. So make sure that you guys understand how to do this. The mostly people make mistake here is one, they don't align the counts and the probability of the color. That's one thing. Another thing students make mistake in this case is the expected frequency. This is the one that a lot of students make mistake here. So be careful with these two careless mistakes that students try to that likes to make here. So that's it for this question.